Welcome to the On-Premise IT Podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a network analyst here at Gestalt IT. And each episode, we bring you the perspectives and talking points from a group of IT luminaries on a specific topic, a premise, if you will. I'd like to take a moment to introduce the guest that will be joining us today before we jump into the premise for the episode, starting with Vince.
Vince Schuele. You can find me on Twitter at Schuele22. And I'm a consultant in service providers and started in the Department of Defense.
Stewart. You can find me on Twitter at Dreaders2. I'm a network engineer at the Energy Sciences Network. So you could say my style of networking is service provider.
Yeah, I'm Chris Cummings. You can find me on Twitter at CrankyNetman. And I am a recovering network engineer, and I am now doing software automation for networks, so configuration management, things of that sort, but also in service provider style networks.
Thank you all for joining us today. Let's jump into the premise of the episode. Now, if you've been doing data center networking or service provider networking, you've probably heard of VXLAN. It was originally a protocol that was designed to solve the limitations of the 12 bits of VLAN headers and be able to allow us to use, identification tagging mechanisms in multi-tenant environments. Okay, all is well and good. Well, then some genius decided to put EVPN on top of it as a control plane. Again, sounds pretty good, right? However, in today's world, you can't say EVPN without saying VXLAN. Just like you can't say TCP without saying IP. You can't say chocolate without saying peanut butter. But do those two things really go together? Do we have capabilities of doing EVPN without VXLAN? Can we use VXLAN without EVPN? It depends on who you talk to, but a quick Google search will tell you that those two things are inexorably linked. So the premise of today's episode, which I thoroughly expect to be debunked and argued at will, is that EVPN needs VXLAN. Who wants to jump in and tell me that I'm wrong?
You're wrong.
Well,
I'll start there.
That was easy.
I would say that the premise is definitely wrong. Like EVPN, as you mentioned, is a control plane mechanism. And I would like to describe it as you basically took Mac learning and took it out of, ARP or NDP and you just threw it into BGP update messages. Now, obviously, you still need ARP and NDP and all that stuff, but it's basically taking the flood and learn portions of Mac learning and just throwing them into a more controllable and theoretically scalable, BGP, NLRI, and all that stuff. It's a whole nother address family and all that. And yeah, you can use all sorts of data planes with it. You can use VXLAN, but I don't think that was really even the primary. I think that MPLS was really where EVPN started off, and then I think EVPN really blew up with VXLAN, with data center switching and stuff like that, because all of a sudden you could use this on commodity hardware that already had VXLAN baked in supporting the hardware. And then you can stretch your layer 2 to your heart's desire and commit atrocities against data center design.
Chris, I'll go off that there as well, right? When you look at a lot of the problems at data centers at scale, it always came down to how many MAC addresses can you put in the ASIC. And then when you went to EVPN, you kind of solved that problem, like you talked about, because you moved, your 40,000 MACs up to a BGP route update, and that just works, right? So now you have all your MAC addresses in BGP, and oh, by the way, if you've been around in data center switching, those switches aren't typically very good at MPLS. They don't have deep labeled stack, so VXLAN became something that was supported and you could use as the data plane encapsulation.
Yeah, I think just to echo your thoughts, I think it's a little bit upsetting that EVPN and VXLAN got pushed and shunted together, right? Because the power of EVPN is effectively what we all know and love, BGP. VXLAN, right, not going to point too many fingers, but it was designed for kind of a semi-specific use case. There's a lot of beauty with coupling EVPN with MPLS, EVPN with even GRE, whatever data plane encapsulation you want. Run it that way, and then run BGP like we know and love.
And knowing some folks who work like on the network vendor space, I know that VXLAN is kind of difficult to work with in hardware. I don't know all the specifics of it, but I think a lot of it has to do with like some variable length fun that you can do in VXLAN headers. And so like, at least from my experience being an end user of EVPN and VXLAN at one point in time, it was really buggy. And now that was sort of the early days, but I mean, getting hardware programming and all that stuff done was really, really buggy. And I spent more times than I would be I spent more time than I can ever get back in the Broadcom shell on certain switches, and that's just not a good place to be. And like I feel like using a VXLAN data plane does have a few drawbacks. I think MPLS is way more stable and way more flexible, and you can do a lot of other just cool stuff with it. And I personally feel, if it's time for a hot take, that VXLAN was used because people didn't really want to learn MPLS in the data center. And as Vince mentioned, like a lot of the switch hardware doesn't support it. But I feel like if there'd have been a push for using MPLS instead of VXLAN, like I think we could be all a lot more better off, because you could have a much more unified data plane other than having to get into things like EVPN stitching, which I know Vince knows about for sure. And that's not fun. So I don't know. That's kind of my hot take on VXLAN.
Chris, I mean, how many times have you heard VXLAN is for the enterprise and MPLS is for service providers? To your point of learning the technologies, you know, MPLS comes with a lot of benefits, especially when it comes to, asymmetric paths, unequal cost paths, traffic engineering.
Yeah, and especially when you get into segment routing, I mean, you can then use that as your TE steering and all that fun stuff. Like, there's a lot of benefits there. Now, I mean, I guess like with a lot of common use cases with EVPN VXLAN, you don't have to deal with a lot of traffic engineering because you're dealing with a flow fabric and everything is nice and leaf spine and balanced and things like that. So it is a valid trade off, I think. And I mean, it's obviously been working pretty well. So I'm not here to just rain on the VXLAN parade entirely, but it does have some drawbacks.
Well, let me bring this up because this is actually an interesting point. I remember being at some field day events in the past and hearing about how VXLAN was going to solve some of the problems that we had. But we already had this east-west side data center story fight going on between the two venerable protocols that were going to solve the problems beforehand, which would be Trill and SPB, which were designed to solve these layer 2 flooding problems. And the funny thing is that when you go back and you look at all the notes, I mean, VXLAN was codified in RFC 7348, but Trill was RFC 5556, and SPB, being the weirdo, had to go to the IEEE, which is 802.1AQ. Why did we not settle on using Trill or SPB as the layer 2 flood and learn protocol, as opposed to deciding to reinvent the wheel with VXLAN?
Well, I think we have shown time and time again that it's really fun to throw things into BGP and just overload it more and more and more and more. And I mean, it does make sense because BGP, it's really extensible and it's proven the test of time. But I think probably a lot of it has to do with the ease of integration. It's just easier concepts to understand, less of a gigantic overhaul of things that like SPB and Trill would be my 2 cents there.
So in essence, what you're saying is that part of the reason why VXLAN was decided was because it was kind of compatible with what we were already using and didn't require a lot of heavy lifting, as opposed to, well, anyone who's been following networking for the past decade knows of the fun that happened in the IETF trying to get Trill approved, and how many different flavors of Trill managed to come out that were all slightly incompatible with each other.
Yeah, exactly. And with VXLAN, all you need is an IP underlay. So, I mean, that really makes things way easier. You just need IP and UDP ability to pass that traffic, and all of a sudden, you've got your overlay, right?
I was going to say that I think the RFC for virtual extensible LAN came out with Arista and VMware both as authors on the draft. So I think, being hardware forward or hardware vendor forward, at least getting their buy-in, put them on as an author on the RFC, there's a lot more traction you get in the IETF versus just coming in saying, hey, we are a protocol. We live in the space of our minds. We have no, allegiance to the hardware realm. You can have two different paths that are quite difficult to traverse.
And I would say that's absolutely the case. And we've seen the same thing over and over again with tunneling protocols like NVGRE or Genevieve or whatever we wanted to call it. But I wanted to touch a little bit on one of the things that Chris brought up about the idea that VXLAN eventually kind of won because there was support for it in the hardware. I can remember that, new switches that were coming out in the 2013, 14, 15 realm, one of their big selling points in the data center was that they had a VXLAN termination endpoint, VTEP. I hope I got that right. Or at least there was an acceleration for VXLAN because they had all suddenly decided that we're going to jettison these other protocols that just sort of kind of work, and we're going to focus on this one. Could it be that that hardware support with these VTEPs, which were hot and new and cool, was the reason why it won out over, say, something like MPLS, which, as you mentioned, was kind of seen more as a service provider protocol. And, I'm not going to run MPLS inside of my network. That's just crazy talk.
Yeah, I think exactly that. I mean, and a lot of people will talk about how Genève is, the better like encapsulation for this, and then probably is pretty accurate. However, tell me where you can run that, and like come back to me, and like it's not gonna you're not doing that, right? And then your best bet, like second best bet would be doing MPLS at this point. So better versus working.
So if I could hazard a guess here, I can tell you how I would do the better protocol. It's recorded on my Betamax tape, and my MPLS discussion is actually on a laser disc if you want to watch that. However, nobody has those machines in their house. They have a VCR and a DVD player, or a Blu-ray player, not an HD DVD player. So I think that we've seen over the course of time that the technologically superior solution usually fails when compared to much better marketing. So is this a case that the providers managed to, or I'm sorry, not the providers, the vendors of the networking gear managed to kind of bifurcate the market to say service provider hardware uses MPLS that's included in this license structure, which is over here. Enterprises use VXLAN, which is included with this licensing and has these hardware components that go into these devices, and ne'er the twain shall meet.
Think definitely marketing has a lot to do with it. To quote Bender from Futurama, I don't like blackmail. It's an ugly word. I prefer extortion. The X makes it sound cool. So I think that's probably why VXLAN won. The X makes it sound cool.
And it sounded a little bit like VLAN, which is something that a lot of people are familiar with. So it wasn't scary like Trill.
Yeah, it really does make a lot of sense that you're like, oh, I understand VLANs. What if I just have VXLANs? Like that's like somebody put flames on the side of it and it makes it go a little faster, right? It's just a little bit better. And that's how a lot of folks use it, right? I mean, most folks who are wanting to use VXLAN are just wanting to extend layer 2 between two data centers so they can do vMotion because they've got a sysadmin that's telling them it's the only way they can do it, and blah blah blah. And I mean, it works. I won't fault it for that. It does work, and it is. And at this point in time, I think it is pretty reliable. And the stuff's like all the real problems are baked out more or less. So I mean, is it worth at this point if you're running an EVPN VXLAN data center to just rip it out and go all MPLS? I don't know. I don't deploy networks as much these days. Vince probably has opinions on that, but like, I feel like if it is working and it's running, like, maybe wait till the next refresh or something.
Yeah, so I could get behind that, right? Like, it generally works now. It's like you mentioned, Genève, right? That's not really in hardware because you mentioned a couple of the problems as the variable linked headers. So really, you're only running that on your VMware. Something running on SEX, and you're running those VTEPs to each other, and then you're going to run that with a .1Q handoff to an EVPN VXLAN fabric, and now you're running EVPN VXLAN or EVPN with Genève on top of EVPN with VXLAN, and you just start burying those encapsulations. And then when you get to your DCI, you're probably going to go and stitch it together with the MPLS handoff so that you can get it over to your other data center and stretch that layer too. But I mean, there's other ways to handle that as well. There's EVPN multi-site where you can isolate those to kind of protect yourself and take advantage of enhancements in the protocol, I guess, so that you don't have this giant layer 2 cluster between globally that is going to explode on you.
Yeah, that is a good point. Like VXLAN is not just for stretching layer 2 between sites, which I've probably been oversimplifying it as. Like it is also incredibly useful even in a single facility, right? Like it is really nice. Like if you want to use all your uplinks and don't want to do MC lag, there you go. And another great benefit, now this is really big in the service provider side, is being able to I can't remember the non-vendor specific term off the top of my head, but Juniper calls it ESI lag, actually do EVPN multi-homing, there you go, between two routers that are not having any sort of peer link of any kind, and you can still run LACP and share that layer 2, that broadcast domain between one endpoint and two endpoints, and that is incredibly powerful and super beneficial. So like there are tons of benefits of EVPN itself, aside from just like WAN stretching kind of stuff.
I want to go back to another kind of thing we were talking about a little bit earlier when we start talking about symmetrical links in the data center, right? The silicon that doesn't have the deep MPLS features is usually a lot cheaper the other one. So what you end up with is you can get a lot cheaper switches that do VXLAN. You have all symmetric links, so everything can ECMP, and it's not as important as in the service provider last mile where, this link might be 100 meg fixed wireless, this one might be 100 gig fiber, and you want to have that tight control over, okay, this type of traffic's going this way, this type of traffic's going this way. Then one other thing I thought was really interesting along this point, and it's going to go back to service provider field day 1, where the latest Nexus OS with ACI has BGP link state so that 5G can do end-to-end network slicing, and that's based on SR MPLS. So you even see, the Cisco data center model going towards an MPLS data plane with segment routing versus just the straight VXLAN.
Yeah, that's a really good point. I do think I guess back to the premise here. I have definitely heard people, when you're discussing EVPN in a service provider context, immediately jump to the premise of, well, we don't want to run VXLAN because we run an MPLS backbone. So I wonder if the if there is an eventual data center migration towards using MPLS as a common, underlay technology or tunneling technology, or is MPLS tunneling? Do we want to get onto that? Like if there is a move to that, I wonder if maybe that'll help kill off some of that, like that just gut reaction to EVPN being a VXLAN thing.
So changing gears here a little bit, I think the marketing behind VXLAN was quite genius, partially because it's not as extensible as we'd like it to be, comparison being BGP. So if I were a vendor and I wanted to productize a protocol, I'd look at VXLAN, I'd say, okay, cut it off at the knees so that we'll fit this simple use case, we'll sell hard on it, we'll sell a bunch of gear, and then when time comes where they want to do, Y on the protocol, we'll have another protocol for them to deploy with a brand new gear. It's kind of smart in that way, right? Because BGP, as extensible as it is, it's not going anywhere.
Yeah, we recorded a podcast recently at Service Provider Field Day 2. I think most of us were here on that one, where we were talking about BGP. Was that? I don't know. Now I don't even remember what it was, but we were talking about BGP recently and how, I think the quote was V4 protocols won't die.
Well, I mean, that's actually a good point, that we kind of we look at the things that are being used currently and we say to ourselves, well, why are those still around? And the obvious question is because they're paid for, or because they don't present a compelling reason to migrate away from them. And trust me, we could record an entire podcast about the whole V4 V6 thing. But I guess the question that I would ask next is there a compelling reason to get away from VXLAN to use something other, MPLS obviously being the next best choice, but what would be the compelling reason to convince people to want to make that wholesale change?
For me, the only thing that would convince me to choose one data center overlay technology versus another would be supportability and interoperability. And at this point, for data center switching, I don't think there's anything better than VXLAN, even though it has flaws. So I would still probably go with VXLAN unless I had a really, really big fat check where I could just, do MPLS, because that obviously has the interoperability side of things. And really a ton of the interop problems are at the EVPN layer more than like the VXLAN layer. So I don't know how much VXLAN really plays into the interop side, but there are still considerations around like the VLAN bundling kind of stuff, and some of that has to do with the hardware that's supported, how the hardware supports it, and how vendors implement it, and all that fun stuff. But yeah, those would be the two primary things I'd be looking at, would be interoperability and just supportability, because it's tough. It is, even though VXLAN is still like less of a lift than what we were talking about with, I guess, BB and Trill. It it's still hard. Like, I remember when I deployed EVPN VXLAN like 3 years ago, and I had the first outage on it, and I just like immediately reached for like my common tools of like, show the MAC address table, and I was like, things have changed. I got to go into BGP. It was like really tough. So like operationally, it's hard. So vendors have the same problems. When I was deploying the stuff I deployed, like I would always get the same people in TAC because it was just a little bit more niche for them, and the first line people just didn't know how to troubleshoot it and things like that. So, you know, it's a tougher realm to be in. So choose the one that's going to make it less tough on you. Would be my 2 cents.
To Chris's point, a lot of the VXLAN EVPN is kind of well baked at this point, and like we talked about, when you have symmetric links and your ECMP, and it works pretty well. A lot of the changing encapsulation at the DCI has also been worked out too. So when you do stitch together VXLAN and MPLS, EVPN is really where you're going to hit those interop problems at this point, where you're going to have to spend the time to figure out how to make that work. The kind of big difference that you might want to consider here is if you're running an MPLS data plane, outside of the paths being different and having better control over that, is you can get fast reroute out of it. I guess you could make an argument that you can get IP fast reroute with TI-LFA, but is that in data center switching right now, or are you really still looking at more traditional MPLS fast reroute technologies to get there?
All right, so let me talk about this, because we talk about the fact that there are external factors that often drive us to change the decisions that we've made when we want to change a protocol or change the way that we do things. And talking about interoperability with people in the provider space, and the fact that VXLAN kind of has this perception of being an enterprise technology. What about the cloud? Because when we deploy a lot of these things, if VXLAN, as Chris has alluded to, is primarily used for things like interconnections, I don't do that in the cloud anymore. Like, there's no vMotion button in the AWS dashboard. So does the impending move of a lot of our resources into a cloud environment from the enterprise to the cloud, not necessarily the provider side, does that change the dynamic of saying, hey, maybe we need to scale back on what we're doing and change what we're working on and reduce complexity in the network? And that means that maybe we're going to dump VXLAN and go to something that our provider not only supports, but can help us with if something breaks.
I think the obvious solution is to just run VMware Cloud on AWS, and then you can continue to stretch your VMs and vMotion all day long and never have to redesign anything. Okay, the non-sarcastic answer would be, yeah, I think like the cloud native principles really do change network architecture significantly, as long as you can move to a fully cloud native application design. Because yeah, you don't need to do any of that stuff with cloud because you design your applications better. Like, I know it's kind of a tough pill to swallow, but as someone who's now a software developer, like, you just can't rely on things like layer 2 adjacency for your HA discovery and things like that. Like, stop it. It's bad. Don't do it anymore. And we as network engineers have been providing, this crutch, I suppose, to keep allowing these things happening in worse and worse ways. And really, it does, I think, a lot of harm in the long term, because, as you alluded to, Tom, we've moved so much complexity out of the applications where it's easy relatively to handle complexity, and into a network where it's hard relatively to handle complexity. And so I would really hope, with the direction of cloud being the way it is, that we are seeing the pendulum swing right back to maybe dumb networks that are just IP reachability. I think we also talked about this with a similar group a very long time ago about enterprises being just a way to get to the cloud. I mean, I think that our data centers and all of our networks are really something that ought to strive for that if we can, and working closely with our sysadmins and app developers to do that. And that's why I think a lot of the future of networking really lives in the enterprise space, or not. That is not the statement I wanted to make. Lives in the service provider space, because I think that those, being able to deliver those pipes at more efficient costs is going to be really the future of things, right? Because, like, a lot of the need for complex networks in a campus or in an enterprise are kind of going away for all the cloud stuff, though. With cloud reaching back onto on-prem with edge computing and all that stuff, we'll see how that changes.
All right. Well, as you can hear from the group of experts gathered on this panel, EVPN and VXLAN really are two separate complementary technologies, but you don't necessarily need to run them both together to see the benefits. You can run VXLAN independently of EVPN. Now, you're going to need to have some kind of control protocol running on top of it. Likewise, EVPN doesn't necessarily need VXLAN as its, well, think of it as the data plane. You can do MPLS or any one of a number of things. The key is that you need to understand the goals that you have. You need to understand what you're trying to do, not just because somebody walked into your environment and said, turn this feature on, and never mind the fact that it causes you to need a more expensive license. You need to understand your technology goals. You need to talk to your stakeholders, including those application developers that have been throwing the complexity hat over the fence for a long time into the network. Maybe toss that hat back and help them understand what you can deliver with the technology that you have. And once you've done that and built a survivable network that has more features than it did before, or maybe you already have that and you're looking to make a change, you'll find that things that maybe not were on your radar before because you didn't think they were possible are actually supportable and may even give you more capability. Don't just take one because you think it's required by the other. Make sure that that is something you have to have. All right, well, that will just about do it for this episode of the On-Premise IT Podcast. I want to thank all of our guests for joining us, and I want to thank each and every one of you for listening in. You can always find the latest episode on our website at gestaltit.com/podcast. You can also subscribe to our YouTube channel, which is youtube.com/gestaltitvideo. Make sure you follow for updated episodes. And if you have a suggestion, perhaps a premise that you'd like to see us debate, please make sure you tweet at OnPremiseIT on Twitter. We'd love to hear from you. We should be back in a couple of weeks with another episode, but until then, we hope to see you soon.